Hello children, how are you? I hope everyone are safe at home. Right. So you know about the physical properties of metals and non-metals. Usually metals are rigid, they are ductile, they are malleable, they are sonorous, they are tensile, as well as they are good conductors of heat and electricity. But coming to non-metals, usually non-metals are non-ductile, non-malleable, non-sonorous, or let me say weak conductors of heat and electricity, and they are also non-tensile. But there are certain exceptions even. Among non-metals, carbon is the exception, as well as in coming to metals, mercury is another exception. Okay, after all the physical properties, let us move on to the chemical properties of metals and non-metals. You know metals like sodium, potassium, or you can take magnesium, calcium, iron, any. So usually metals, they are completely different from non-metals in their chemical properties. And you know about in the previous lessons you have learned about acids and bases. Usually now here I'm just connecting the metals or the substances which give rise to bases, and non-metals gives rise to acids. That means metals react with oxygen to give metallic oxides which are basic in nature, and non-metals, they react with oxygen to form non-metallic oxides which are acidic in nature. So now I'm going to explain you that metallic oxides are basic and non-metallic oxides are acidic in nature by giving some examples. Right. Now, here as I said, let us see how these metals react with oxygen. Now, I'm just taking certain examples. Sodium. Sodium is a highly reactive metal. It is stored under kerosene. It is kept away from the exposure of oxygen as well as water. It is stored under kerosene or paraffin wax, right? So this sodium, which is a highly reactive metal, it reacts with oxygen. Look at that. Then what is formed? An oxide is formed. Here we call it as sodium oxide, right? Na2O, sodium oxide. And this is an unbalanced chemical reaction. We need to balance every chemical reaction. So here 2 sodiums. If I put 2 Na, then it won't be balanced. So I'm arranging 4 here and 2 here. 2 2s are 4 sodium, and 2 oxygens, and here also 2 oxygen. This is how we have to balance a chemical reaction. In the same way, the next example I'm taking is magnesium. Magnesium reacts with oxygen to form magnesium oxide. You know about how we'll be seeing a white sparkling light when we burn the crackers like ribbons and all. There, metal magnesium reacts with oxygen to form magnesium oxide, producing intensive white sparkling light. It's an exothermic reaction. So here magnesium oxide is obtained. The formula of magnesium oxide is MgO. Now this is also unbalanced, so I'll be arranging 2 here and 2 here. Magnesium reacts with oxygen to form magnesium oxide. And then again I'll be taking another metal, namely copper. The symbol of copper is Cu. Cu plus O2 gives rise to CuO, cupric oxide, which is black in color. Here magnesium oxide is white and cupric oxide is black in color. Here also I'll be arranging like that. So these 3, look at this, sodium oxide, magnesium oxide and copper oxide. These 3 are metallic oxide, and I tell you that these metallic oxides are basic in nature. How can we prove that they are basic in nature? Like for example, if I take Na2O, sodium oxide, if it is made to react with hydrochloric acid, HCl, so I'll be taking some sodium oxide and I'll be putting it in hydrochloric acid. Then you are obtained with NaCl plus H2O. You have to balance. So here 2 sodiums, I'm arranging 2 and I'm arranging 2. So here you know that this is an acid. When a substance is reacting with an acid and it is resulting into a salt, definitely, obviously that particular substance is a basic substance. This is one of the important example which proves that metal oxides are basic in nature. In the same way, I'm taking copper. I'm taking cupric oxide, CuO. This cupric oxide is black in color. Remember, cupric oxide is black in color. This is solid. And I'll be taking again dilute hydrochloric acid. So I'm writing HCl. Then you are obtained with a bluish green colored aqueous solution where CuCl2, cupric chloride, is formed. This is bluish green and this is aqueous, and along with that water molecule is also obtained. You know, cupric chloride is a salt. A salt is obtained when an acid is reacting with a substance which is basic in nature. So definitely I say this cupric oxide is basic in nature. So metal oxides are definitely, we can say, they are basic. So here we go. Metals react with oxygen to give certain metal oxides, and metal oxides are basic in nature. These are the two important examples which can prove that metal oxides are basic. And coming to the non-metallic oxides, you know about non-metals, like you can take carbon, you can take sulfur, you can take nitrogen as examples. Carbon reacts with oxygen to form carbon dioxide. Sulfur reacts with oxygen to form sulfur dioxide. Even nitrogen reacts with oxygen to form many types of nitrogen oxides, like nitrogen dioxide we can say. And these oxides, when are diffused into the water, they are producing acids. You know about carbonated water, all aerated drinks. These aerated drinks consist of carbonic acid. So here we go. We'll be explaining non-metallic oxides, or first of all let us take non-metals. I am taking carbon. Carbon, the symbol of carbon is C. This C reacts with oxygen to form carbon dioxide, CO2, right? And then I'm taking another example. Yes, sulfur. Sulfur reacts with oxygen to form sulfur dioxide, and the formula is SO2. And you can easily understand that these are balanced chemical equations. Then I'll go with nitrogen. Nitrogen reacts with nitrogen. I have to put it as En2. Nitrogen is a diatomic molecule. Nitrogen reacts with oxygen to form nitrogen dioxide. So now NO2. Now we need to balance the reaction. How do we balance the chemical reaction? So here nitrogen dioxide. See here two oxygen atoms and here two oxygen atoms, but here there are two. So what shall I do? I'll be putting 2 here. If I put 2, here you can see carbon dioxide and sulfur dioxide. These are certain non-metallic oxides. If this carbon dioxide is poured into water, diffused into water, that carbon dioxide is diffused or let me say pressurized into water, then you are obtained with a reagent H2CO3. You can observe that it's a balanced 2 hydrogens, 1 carbon as well as 3 oxygens. So here carbonic acid is obtained. This is carbonic acid. The aerated waters consists of this acid. Now in the same way, if I take sulfur dioxide, when this sulfur dioxide is again diffused into the water, you are obtained with another reagent, namely H2SO3. We call this as sulfurous acid. Sulfurous acid. So here you can easily understand that non-metallic oxides like carbon dioxide and sulfur dioxide, they are giving us carbonic acid and sulfurous acid. So this proves that these non-metallic oxides are acidic in nature. So once again I tell you, usually, so most of the metal oxides are basic and most of the non-metallic oxides are acidic. So I hope everyone understood. With the examples you have to go through and you have to practice. And in the coming video I'm going to explain that there are certain metals which are both acidic as well as basic, and they are called as amphoteric oxides. And what are amphoteric oxides? In the coming video I'll be explaining you. Hi children. In the last class, I was explaining you that most of the metallic oxides are basic in nature and most of the non-metallic oxides are acidic in nature. Yes. In nature, there are certain metals which are both acidic as well as basic. Yes. certain metals like zinc, lead as well as aluminium, they are both acidic as well as basic. Such type of metals are called amphoteric metals, and their oxides are called as an amphoteric oxides. Now today I am going to explain you with reactions what are amphoteric oxides, right? So here, aluminium oxide. Aluminium oxide, the formula of aluminium oxide is Al2O3. This Al2O3 alumina or aluminium oxide reacts with both acids as well as bases. It reacts with HCl to form aluminium chloride, and it also reacts with an alkali, namely NaOH or KOH, to form certain salt, so like sodium aluminate. So here we go. I'm taking an example, Al2O3. This is called aluminium oxide. Aluminium oxide reacts with hydrochloric acid. See here, you have to understand, this is aluminium oxide. Okay, this is a metal oxide. And here I am taking dilute HCl, which I'll take it as aqueous, and this is solid, and this is like hydrochloric acid. Hydrochloric, this is definitely an acid. Remember, this is an acid. Now, when these two substances react with each other, here you are obtained with AlCl3, aluminium chloride. Remember, aluminium's valence is +3, chlorine valence is -1. So, the formula of aluminium chloride is AlCl3, and this is a salt, and it is a neutralization reaction. So here water molecule is eliminated, right? This is we call it as an acid base reaction. And here, when this is an acid and this is a salt, here aluminium chloride is a salt, and when this acid is coming in contact with a basic substance, this salt is obtained. So here I am considering this aluminium oxide as a basic substance. As I tell you, aluminium oxide reacts with hydrochloric acid to form aluminium chloride and water. This is the first phase of type of reaction. Now, in the second type of reaction, the same aluminium oxide I am taking, Al2O3, but now this aluminium oxide is coming in contact with an alkali. You know about alkalis. What are alkalis? Water soluble bases are called alkalis. Strong bases are called alkalis. Now I am taking an alkali, namely NaOH. NaOH is sodium hydroxide, which is an alkali. Alkali in the sense it's a strong water soluble base. So here this is a base. Now, before here I took an acid, here in this case I am taking an base. When this sodium hydroxide, which is a strong base, come in contact with aluminium oxide, this aluminium oxide, it starts behaving like acidic. So it would be acidic now. Now, in the before case it is basic, but in the second case it is acidic, because here also a salt is formed, namely sodium aluminate. Sodium aluminate is NaAlO2. So the formula of sodium aluminate is NaAlO2 plus H2O. So here we call this as aluminium chloride, which is a salt, and here we call it as sodium aluminate. This is also a salt. So in both the cases salts are formed, but the nature of aluminium oxide is different. In the previous case it is basic, and in the later state it is acidic. So such type of oxides which behave both acidic as well as basic, when they come in contact with certain environment to produce salt and water, are called as amphoteric oxides. The metallic oxides, which behave both acidic as well as basic, are called as amphoteric oxides. Remember children, we need to balance every chemical reaction. Here you can see in the upper one there are 3 chlorines, and here only 1 chlorine, and here 1 aluminium and 2 aluminiums. So keeping in view all that, we need to balance. So I'm just putting here 2. If I arrange 2, 2 3s are 6. So here 6. and then there are 2 hydrogens, I'll be putting 3. So it is a balanced chemical equation. In the same way, in the second case also, Al2O3, and here I'll be increasing to NaOH, and then here I'll be arranging 2, then once check it, here 3 oxygens and 2 oxygens, and there here I have to write H2O. Now it is balanced, right? So once again I'm telling you, the metal oxides which are both acidic as well as basic are called as amphoteric oxides. And example, zinc oxide is amphoteric, aluminum oxide is amphoteric, and even lead oxide is amphoteric in nature. Okay, so in the coming class I'll be explaining you how to prepare sulfurous acid. Bye.